Hi, so today I want to show you a tool that you can use to draw structures for your chemical reports or just to actually investigate different structures and use those to visualize in 3D, measure bond angles, bond lengths, and things like that. The program is molview and it is available online at molview.org. What this means is you just type in molview.org and you'll get this splash page here. We're just going to hit close. And the first molecule that they bring you up here is actually one of caffeine, and you can see that it gives you a good picture of the caffeine molecule and also renders it in 3D. But we don't want caffeine, we want to use this to actually draw some of our own molecules. So I'm just going to select the lasso tool here, select the molecule, and hit delete to get rid of that. We are currently studying hydrocarbons, so let's have a look at a couple of options that we have for drawing hydrocarbons. We can select the atoms that we want to draw with down the right-hand side here. So I'm just going to use carbon. I'm going to draw a pentane molecule, so 5 carbons, 1, and then I'm going to click and drag for 2, 3, 4, and 5. So when I want to add a new one, I'm just clicking and dragging up to add the new one. If I just click on it, it just replaces that atom. Now I've got my 5 carbons, I want to get my hydrogens in. So I can actually hit this CH here and that will scroll through the different options. So our skeletal structure where all the carbons are removed and then carbon and hydrogens being visible here. I can also, if I've got a skeletal structure, just draw out my hydrogens. If I want to, I can just click and drag like we did with the carbon atoms to put my hydrogens on. But it's a bit faster doing it this way. Once I have all my hydrogens in with my carbons, I can use the little broom icon here to clean it up and it will shuffle it around a little bit and put it all with the correct bond angles. So we can see we have the zigzag conformation with our hydrogens coming off each one. Now that I have this drawn as a structural diagram, I can actually go into Tools. I can download the structural formula image if I was wanting to put it into a lab report or an IA. I can download the image and then just put it into any document, or I can just take a snip of it from the screen if I wanted to, but nice easy way to draw our compounds. But if I want to look at it in 3D and measure some bond angles, which is what I want to do, I'm going to hit the 2D to 3D button. It's going to think for a little bit and then it's going to throw it up in 3D. When you're using it for the first time, you might get a little bit of a warning that just says they may not always be accurate. So you just click that away and you can have a look. Now we can drag this around in 3 dimensions and have a look at the molecule, as we can see here. Okay, so we've got our pentane molecule here. Now that we have it in 3D, there's a few other things that we can do with it. We can go to this JMOL tab up the top. High quality will make it nice and pretty for when we're downloading images, but might make rendering a little bit tough depending on your connection. Then if we have things on it that we want to get rid of at any point, you just hit clean and that will clean up the structure for you. So let's have a look at how we might measure bond angles. We're going to go into JMOL. We're going to go down to angle down here. And then we're going to click on the center of the atom that we want to start the angle to the next angle. And then we're going to make our angle here. And we can see that the angle between these 3 carbons is 111.5. I can then go in and select another angle if I want to see the angle between these hydrogen atoms. I can go in and measure that as well. But so we can see here is our angle. If I want to clean that one off, I just hit clean. Now I'm going to go in and have a look. I can see the angle between these 3 atoms here is 108.3. So I can record that angle. And I can even record the bond distance between my 2 carbon atoms here as 0.152 nanometers. So with this, we can record angles of different molecules, we can have a look at them at 3 dimensions, and then we can even go now and we can go into tools and download our 3D model image of this one here and include in our document. Energy minimization will just shuffle the molecule around a little bit to put it in its lowest energy conformation, and that will put it in its most accurate bond angles. You can have a little bit of play. Where the surfaces here, you need to have a polar molecule for those to turn up. We can place charge on each of them, and we can see that there is no charge differential or no partial charge differential between any of these atoms, which makes sense because it's non-polar. Then just hit clean, and that will take all my labels off. That's all I wanted to show you for now to get you started on the activity and building your own and creating your own molecules. And I'll see you next time.